Welcome everybody for our fourth webinar at Light and Shadows. I'm Chloe. I'm just going to present the beginning of this webinar, and then I will let Alexander and Mathieu present the whole presentation to you. So it's a webinar between Light and Shadows and Navis, and it's about the acquisition and exploitation of point cloud data. So I'm going to let the two presenters present themselves. And just, excuse me, just if you had any question, ask them in the chat, and we will take time at the end of this webinar to answer them. Thank you.
Thank you, Chloe. So I will start. My name is Mathieu Klucker. I represent Navis today. I'm a senior enterprise account executive, and I focus specifically on France and Benelux. And it's my pleasure today to join Light and Shadows to explain how Navis does the scanning part, and let Alexandre explain the part about the use of our data in their solutions.
And I am Alexandre Avenel. I am product manager of Steeple and Interact at Light and Shadows. And as we will see, Steeple is our tool to import a large point cloud into Unity and to do a lot of use cases for many industrial purposes. So we will see how to exploit and have a better return of investment with your point cloud data. So thanks a lot, Mathieu, to be here today. We will see that acquisition and exploitation are tied together, and this is really great to have the full workflow explained in the same webinar. Maybe a few words about Light and Shadows to start. Light and Shadows is an virtual reality and XR reality provider. We mainly provide high-end rendering images for automotive fields, for example, but also we have a part of our company dedicated to the development of products for industrial, and Steeple is in this part of the company. We aim to develop XR usage for industrial companies.
A few words about Navis. Navis is a Munich-based company that was founded in 2013. The company comes from the Technical University of Munich. The company has already known quite a rapid growth, and today we're already over 200 employees worldwide, and we're separated into several offices. Most of the people at Navis are still in Munich with the whole development team, project teams, sales and administration for Europe. And we have an office, a couple of offices actually in the States, New York and Shanghai, and an office in, New York and Los Angeles, and an office in China, in Shanghai. Today, Navis has already over 250 customers. And in terms of the customers of Navis, we're talking about, on the one hand, customers that are laser scanning professionals or surveyors that use our hardware technology. And I will come back to this hardware technology in a couple of slides. They use this technology to do projects to scan facilities, create maps, create models, BIM models. That's the one type of customer. The other type of customers are enterprise customers, for which our offering is based on first a service offering for the creation of digital twins, and that's something that we do relying on a network of partners that we have in over 30 countries. And the second part of what we offer for enterprise customers are software solutions. And the main solution here is a platform called Navis Ivion. I will touch briefly on this topic today, as Ivion is a platform that allows our customers to access their 3D data and also to export the 3D data to be reused in applications such as the one from Light and Shadows. I think we can move to the next slide. A little bit of history to start off. The topic of 3D scanning is not new. It was not invented by Navis. Actually, devices to capture the geometry and make measurements using lasers are already out there since a few decades, starting in the 1980s with what have become known as total stations. These devices are still around today, and they are devices that are used for doing measurements with a few points being measured per minute, measured manually and measured from a static point. So we refer to these devices as static devices. The technology around laser scanning has evolved over time, first with the development of devices that increased drastically the number of points that were measured per minute, even per second. So moving from a few measurements being done per minute to millions of points being captured per second. These devices are usually referred to as terrestrial laser scanners, or TLS. And this is the most common type of devices that people think about when they think of 3D scanning. The limitation of this type of device is that you are, even though you're measuring lots of points, you're still measuring these points from fixed locations. And therefore, there is a low agility and low efficiency in the speed at which you can scan things. This is why technology called mobile mapping has been developed, and Navis played a major role in the development of this type of technology. First with a device that has evolved over time. Today we call it the Navis M6. That's the device you see on the right-hand side of this slide. And this type of technology, with the difference with the TLS technologies, that the scanning happens in motion. So we're talking about mobile devices. And the main objective that we pursue with this type of technology is to gain efficiency on the speed, scanning fast while making as little compromises as possible on the quality and the precision of the resulting scan. Chloe, if you want to click once more. Very recently, actually last year, just about a year ago, we launched a new device called the Navis VLX, which basically is the same type of technology as the Navis M6 that you saw on the previous slide, but on a portable device. So here again, we're talking about a device that continuously captures the 3D geometry of the building and also captures pictures. And the combination of the two, the pictures and the point cloud, in the end creates what we call the Navis digital twin. And I'll come back to that. Just a couple of more words on the Navis VLX. The agility that we gain by having a portable device allows us to have much more complete scans of the facilities we're scanning. And this is really the best of both worlds. We have really the high quality through very advanced algorithms that are applied on the data we capture. And we have, through the agility of the device, really the completeness of the scans that we're doing of the environment we're scanning. The result is very complete in having captured everything from all possible angles. But as pictures are better than 1,000 words, let's move on and have a look first at a small video that illustrates the process of scanning and the device. I'm going to comment because the sound doesn't come through. So this video shows you the type of results you're getting by scanning with the Navis VLX. Actually, you get the same type of results with the Navis M6, but the VLX has more flexibility in the way we scan. The device is composed of components that capture the 3D data. These are the LiDARs, and cameras that capture the pictures, and the device includes a display that lets the user know very easily how much has been scanned and how much is left to be scanned, and actually makes this device very intuitive and easy to use while delivering high quality results. As you can see here from this, what we call this point cloud fly-through, the result of the data is a very complete scan representing the whole geometry of the building that has been scanned. And you can see here that you will get really all the details. And Chloe, if you can move to the next slide, I'd like to explain, first of all, why is it that we're getting really, or why is it that we're having such advantages in terms of speed of scanning. To illustrate that, let's use a small example of a facility here in a building that would be actually more representative of an office type of environment. But the same will apply also in an industrial environment. You can see quite easily here that on the left side, where we show how this environment would be scanned by a terrestrial laser scanner or a fixed scanner type of device, you would need to position the device at multiple locations, actually as many locations as there are rooms at least, and usually even with several locations per room. And therefore, taking into account the fact that from each location you need to let the device run for several minutes, you can easily, in such an environment, end up scanning for something like 20 minutes. Whereas, and let's turn now to the right-hand side of the screen, if you are to scan the same type of environment with a mobile device, you don't need to stop anywhere. You're just browsing through the facility and capturing the 3D data in a continuous manner, and therefore you can scan this in much shorter times. In this example, we evaluate that instead of 20 minutes, you could scan that in 5 minutes. This is just an example, but it's not untypical to have gains of factor of 4, 5, sometimes 10, or even 20 in the most complex environments. Scanning in motion really brings the efficiency in terms of the speed at which we can scan. And this is not just an advantage in terms of spending less time and therefore less money in the scanning part. It's also less disruptive, and this is probably even the most important and most valuable outcome of scanning in motion, especially in industrial environments. The disruption on the production is really minimized by scanning fast and avoiding to stop production for extended period of time. Let's move to the next slide, if you will. As I was saying, the advantage is gaining speed while maintaining the highest level of accuracy and result quality. So here, with a couple of slides, I'd like to give a couple of examples of results that we get from the VLX scan. What you see here in the background is not a picture, it is a point cloud that has been colorized. So the 3D data that is represented in the form of this point cloud can be enhanced with colors or color information that we get from the pictures, resulting in a point cloud that's very intuitive and also very appealing. Let's move to the next slide. And same picture taken from a little bit further. Next slide. And the result is also quite remarkable in typically complex environments for traditional scanners. And again, the point I was making earlier, the two aspects, the precision, so having high quality results, even of reflective surfaces and things that are typically difficult to scan, but also the completeness of such an environment here. through the fact that we're scanning and moving around the pipes and around everything that's in the room that we're scanning, we're really ending up with a very complete set of data that really represent the object in all of its aspects. Let's move to the next slide, which shows you an overview of what Navis offers also in terms of software, focusing on our offerings for enterprise customers. Once the data has been scanned, and I don't go into details of everything we do in what we call the post-processing phase. Once the scan has been done and the data has been post-processed, the data is made available through a platform that we call Navis Ivion. And this Navis Ivion platform has a specific enterprise version, which lets our customers access their facilities and consume the data and collaborate on the data, on the 3D data, and on the pictures. And one of the aspects of this platform is the ability to extract information to be reused in third-party applications. Maybe just one last word before I hand over to Alexandre. In addition to this platform that is more of a desktop type of solution, we have also developed a solution that's called Navis Ivion Go, which basically brings the ability to navigate, to access the digital twin from the shop floor with an application or an app that can be installed on mobile devices and solves the question of positioning in the digital twin with a solution that relies on recognizing the pictures and therefore solves the problem of not having GPS signals inside the building. But that's not the topic of today. The topic of today is how the data that you can access through the Navis Ivion Enterprise solution can then be further valued and used further in more use cases. And let's, with this, hand over to Alexandre, who will tell us how this data can be used in Stipple and more generally in the light and shadows applications.
Thanks a lot, Mathieu. In this part, so as Mathieu said, we will see how to exploit your point cloud scan and especially how to do some simulation or some custom application that will fit your industrial workflow. So for this, we will present our new tool, which is Stipple. Stipple is a quite young plugin that we released a few months ago. And this is created here at Light and Shadows, and it allows you to deal with very large point cloud into Unity software and edit them, do some simulation, do some clash detection, comparison. We'll see all of these use case in a few slides. So a few words about Unity first. Stipple is a plugin for Unity, and Unity is one of the leading platform for real-time 3D rendering. This was usually made for video games, but since a few years, displaying a lot of 3D data is also useful for industrials, and they let industrials use Unity to create a lot of application. This is a really great ecosystem with a lot of tools, and today we will see how to combine tools. Stipple is ready to deal with point cloud, but the key takeaways is that with Unity platform and Stipple, this could be the basis of your digital twin strategy when you want simulation, integration, custom processes, when you want to mix some data. So let's deep dive into Stipple. This is a video that has been a bit accelerated, but it's just to show you the full experience of Stipple within Unity. So this is Unity platform, and in a few clicks, I have been able to import my point clouds from Navis. It was in E57 format, so it's a well-known format for point cloud import. We are also able to handle LAS format and PTX format. And first thing to notice is that we are able to display very, very large point cloud. We have in-house streaming technology. This is on your computer, but points are displayed only if they are needed. And this is why on just a laptop computer, this is not a very high-end system, I can display hundreds of millions of points without any problem. This one is 160 millions of points and it runs very smoothly. Then we have quite a lot of visualization features, so you can customize the display. Here we have enhance the edges to have a more powerful lighting models. You can navigate in your point cloud. You can colorize the point cloud. You can even edit to remove some unwanted objects. We will talk about this a bit after. But since we are in Unity, this is a 3D platform, and we will be able to mix 3D data. And beyond the tool of Steeple, this is something really cool about this solution, is that every feature of Unity is also usable with Steeple. Steeple is key to have your point cloud data, but in Unity, we will see that you can also import CAD data, BIM data, any 3D data, you can import this in the same scene. So here we have seen how to set up the scene. We have some tools like let's put a skybox to have something really nice as an environment. How to import a 3D model in the scene, like the forklift that we see at the screen right now. And we can also do some animation if you want to check that if you want to check some paths, if you want to really animate all your scene, you can really blend 3D data together thanks to Unity platform. Steeple is really here for the point cloud rendering, but it's really blend with Unity rendering pipeline. So you can mix all of those things together. This is really useful because capturing a scan is really to have the present, like how your facilities is today. But with 3D, we can also predict the future and say, okay, how will it look with a new machine? What if I want to plan some construction work? What if I want to check the accessibilities of some parts? All of this is available thanks to the ability to mix 3D data. So here, just to for the last part of this video, we see also that any Unity animation features is available. So if you, for example, here we will try to animate the forklift, and we will see that animate in the scene. When you are done with animation, 3D data, point cloud, you can export your application as an executable. So people don't need to have Unity platform to view your application. And you can also develop your own behavior, program your own events. Like, for example, here we see how to add some audio sources into the scene. So when you navigate in the scene, you can also have sound. Pretty much everything that is possible in a game engine, you can also have this in your application. One thing also, thanks to Unity, you can also view your application in a lot of devices. For example, virtual reality is available. This is really a few clicks away to view your whole point cloud in virtual reality to have the full scale of your 3D data. Just a few words. I talked quite a lot about mixing 3D data in Unity platform, and this is really what is powerful with Unity, is to blend Steeple together with other tools. And we can recommend, for example, if you want to import CAD data, native CAD data like CATIA, Autodesk, SolidWorks, and you want to have all of this together with your point cloud, you can use, for example, Pixies, which is a well-known plugin in Unity platform. And this is a very cool addition to Unity and Steeple. If you mainly have BIM data, for example, Revit data, we can also recommend Unity Reflect, which is a connector to import and synchronize Revit data into Unity platform. So with those tools, you can really create a custom platform that will fit your workflow. This is you can really customize and implement your own workflow that will take into account all your specificities. So when we have all the 3D data in the scene, there is a few more things that we can do with Steeple. And one of those things is clash detection. The feature will come very shortly in our next release, but let's have a look on what we can do with this. This is mainly intended for planning purposes and check that a machine will fit in a dedicated workplace. Imagine that you want to install a new machine, for example, this robot, and it's quite difficult to have access to the factory, to the facilities. So you can do a scan. This is a quick way to have an accurate and up-to-date 3D blueprint of the reality. And you can import your new robots that will fit into this place in the 3D scene. You can also animate robot trajectory using Unity, or if you want more physics simulation, we also offer some simulation plugin like Interact, which is also developed at Lighten Shadows. Thanks to Steeple, you will be able to detect in real time clash detection between point cloud and mesh data, 3D data. This means that your robot, you can play the whole trajectory, the whole path, and see if there is any risk of collision. This will help you plan any work to install your robot and see also if you need to modify the trajectory, the path of your robot. All of this can be done before building the real thing, and it will minimize the stopping of your production line, and you can really have predict the future and anticipate risk using this. It was maybe a bit quick, but in those videos, there was some part of this robot that switched to red when there is some clash, and that goes back to normal when there is no clash. Another completely different use cases, this time using BIM data. This was made by Unity Japan, and they happen to have a very accurate BIM model of the office, and they also add a point cloud of the office. So they register point cloud and BIM data together, and you can see that using cross section, BIM data and point cloud match quite accurately. And thanks to Steeple, we can compare point cloud and BIM data. And in a few clicks, we can see any differences between those two. And for example, here we can see that the projector and speaker were not in the BIM data, but all the air conditioning system seems quite accurate. We also noticed some differences on the light and the background. The lights are not exactly placed like in the BIM model. This is useful for two things. The first one is to check if your construction is built as designed. So you can check construction, and thanks to mobile mapping, like Mathieu showed us before, it's very easy to do a lot of scan during your construction work and compare scan from time to time and see if there is any differences on what you expected, what is on the blueprint, and what is realized. This is one of the use case, and comparison feature will quickly help you spot any differences in those cases. There is also another use case is when you want to have an accurate and up-to-date digital twin. When you build your facilities, maybe your digital twin will be accurate and up-to-date. But when your factory evolves, you might have some contractors that add some pipe somewhere, or you might need to move some machines someday. And it's very, very difficult to maintain accuracy of your digital twin. Thanks to scan, you can thanks to mobile scanning, you can scan your facilities and compare the result with your digital twin. And you will quickly see which part of your digital twin, which part of your BIM model you will need to update to match the reality. So this is really working two-way here, from the BIM model to the reality, and from the reality to the BIM model. This is only a small overview of what is possible with Unity and Steeple. We had quite a lot of customer or enthusiast people that tried a lot of things, and we also did quite a lot of tests on our side. And for example, with all those familiar Unity tools, you can also extend the possibility of Unity and Steeple. One of those is, for example, Furious. Furious will allow you to stream your project on a web browser, so you can view this in a web page. This is streamed directly from a cloud, and you just need a browser to access your Unity application. If you are interested about more simulation, and especially human-centric simulation for all your industrial processes, like how to simulate an assembly sequences, how to validate that some part is fitting in some tight area. You can also use Interact, which is the other tools that we develop at Light & Shadows. So if you want to talk about this, we can also direct you to some people on this. And the last one, which is also something very cool, is that you don't need to be a developer to customize and to have some specific behavior. Unity now integrates bold visual scripting, and with a few clicks, you can design your own behavior. For example, how to play a song if I go to one part of my point cloud, how to move and how to navigate in my point cloud. If you want to make some 3D model appear at some times, everything like this is very easy to do in Unity, and thanks to Steeple, you have all the tools needed to really push forward your use of point cloud. Not in this slide because it was really a test that we made a few days ago. We also tested NVIDIA CloudXR, which is a solution to stream your point cloud and your application data in iOS or Android devices. This is working really well, and this is also to illustrate the power of Unity ecosystem. We will handle the part about point cloud, and we will let other plugin and other tool in the ecosystem to handle other specific tasks. And you need to imagine that this is a big bag of Lego brick. Each brick is a new technology, and you can combine them to build your perfect tools, so that it's really fitting your existing workflow and your specificity as a company. So this was the end of my presentation. Of course, we still have plenty of time to answer questions about mobile scanning, VLX, Navex tools, but also Steeple and the use cases you want to do. So feel free to ask a question. We love to answer them. So let's see if there is any already. Okay, maybe let's. First question: is the point cloud exposed or in some logged format when delivered to client in Unity project build exe file? No, the raw point cloud is not exposed. We convert this point cloud to an internal format, which is part of the magic source that allows us to display very large point cloud. So point cloud is part of the final application. You don't need any cloud connection. You don't need to have some external files. This is packaged into the final application, but it's not the E57 format. And yeah, as Mathieu said, with Navis, you can quickly export E57 files, which is something that plays really well with Steeple.
I actually realized that I misunderstood the question, but you gave the answer, Alexandre, the more proper answer to the question.
I think the next one is for you, Mathieu.
Yeah, I can actually answer the first part of the question about whether we deliver a mesh model alongside with the point cloud. No, we don't. So Navis is focusing on creating a point cloud of high quality and making this point cloud as well as the pictures available through our Navis Ivion platform. Taking the point cloud and converting it into mesh is something that is possible through third-party software based on the data that you can export from our platform, but we don't do it. And I guess the part about having large-scale information becoming very laggy in Unity is usually exactly why Light and Shadows has developed the Steeple application. So I guess you can take the second part of the question, Alexandre.
Yes, one main goal of Steeple is being able to load very, very large point cloud. So billions of points, it will load into Unity software. We are able to display this, so we are not afraid of big and dense point load. And this is also something that will make your workflow easier. I understand that 3D model can be very useful in some case, and model 3D things from the point cloud is really useful sometimes. But when you really want to have like full scale model, convert everything to a 3D model will be very time consuming. With Steeple, you can have the view of your whole point cloud directly, and it shouldn't be laggy. We worked a lot for this, but we still love to be challenged about this. So if there's any point cloud that is a bit too large, we will see that as a our developer will see that as a challenge, and we'll try to display it. But yeah, I think it depends really on the use case, and point cloud data is something really easy to acquire and should be also easy to visualize. You will need to resort to 3D remodeling when it's really necessary, because it's a time-consuming process, and you don't necessarily need this for every task. Is clash detection dynamic and available in exported exe file? Yes, it's dynamic, and so you can even do some clash detection with some user interaction. if you have some meshes around. And we do this a lot with some, when we combine, for example, with Interact, which is our tool for human-centric simulation. Human can manipulate tools, and if there is any clashes between point clouds and the tool, you will see that in real time. So we don't bake anything for this. This is really real-time computation. And also, yeah, it will work with the exported exe file. If you are using a point cloud in Unity for virtual reality, does it work well on standalone headset like the Oculus Quest 2? Oculus Quest 2 is not yet supported directly from Steeple, but we made some tests with NVIDIA CloudXR to stream from a machine to Oculus Quest 2, and it works really well. Other things that is possible is to use Oculus Link, and it will also works well. You still need for now a PC to compute which points should be visible at all time, but the rendering devices could be Oculus Quest 2. And okay, this one is more Unity specific. Unity has 4 GB limit for assets, so other Steeple handle limits in Unity. We use our own algorithm to only display point clouds that contribute to the final images. So we had no problem dealing with a very large point cloud. I think that 2 weeks ago, I had a customer who convert point cloud, which was 70 gigabytes, and it's not our best. I have seen something like 100 gigabytes, and it also works. And if you really have some limits on this, it's also possible to. We are working with some people to stream this from a network drive, for example, or something that will have a large capacity to avoid the need to have the point cloud locally on your machine. Can Steeple run over Furious with very large point cloud? Yes, just a warning, since Furious need to be deployed in the cloud, the initial loading time, if your point cloud is quite large, might be a bit long, especially if your machine is instantiated on demand. So you don't have the machine running like every hours. So the initial loading time can take a while, but after that, we have tested this with, I think on Furious, so we tested something around 16 gigabytes of data through a web browser. But there was also some other 3D assets, not only point cloud. So there was also a bunch of car models and truck in the highway to simulate all traffic in a portion of scan highway. I have worked with KGRO's plugin PCX in order to import the point cloud into the Unity. There, I cannot light up the points. Points do not reflect the light, for instance. Playing with light is not possible with that plugin. I wonder that with Steeple plugin, is it possible adding a point light to the scene and see the lighting into the point cloud environment? So great reference. PCX is a great tool. The only problem with PCX is that it does not handle the out-of-code technology, the technologies that we use to display very large point cloud. For lighting, we are working on this. but this is not available right now in Steeple, so stay tuned for this feature. This is something that is asked a lot and that I would love to play with. And we have something ongoing for this. We made a few tests. We have some results internally, but nothing to share right now. So stay tuned. Next one is for you, Mathieu, I think.
So I will definitely have a very biased answer to this question. The VLX, I would say the main difference is the ability to record anchor points. To my knowledge, this is not possible with the BLK2GO. And this is one aspect that allows our VLX to produce very high quality results. I need to go a little bit into the technical details here. When you scan in motion, you have the added challenge compared to scanning from fixed positions that you are creating a point cloud and therefore creating a map of the environment you're scanning, and you're moving within this environment. So you're moving within the map you are currently creating. So you need to be able to know at each point where you are, and therefore all the mobile devices have so-called SLAM algorithms. SLAM stands for simultaneous localization and mapping. And SLAM algorithms basically correct or answer the question, where am I in the 3D point cloud that I'm currently capturing? And as a problem is usually answered with always a small error, an error called the drift accumulates as you are scanning, and as a result, the scan that you do is slightly bent. It's not perfect. And one way to correct this bent is to record so-called control points. And this is one aspect where the VLX has really a very powerful workflow for recording the control points and use this information in the post-processing phase to enhance the quality of the result and reduce the drift to a very high extent. That's, from my knowledge, a big difference that makes the VLX produce better results. I believe the results speak for themselves. So if you go out there in forums of people comparing the two technologies, you will probably also find pictures comparing results from BLK and results from VLX. Also on the visual aspect of the pictures, the VLX produces much higher quality results. But I think in the end, the precision is probably the more important aspect, and in that regard, the VLX produces higher precision than the BLK2GO. But I guess the best way to do that is to test both devices. Invite us to come and do a test with the VLX, and invite the guys from Leica to go with the BLK and compare the results, and then you'll be able to make an educated decision.
So what is the name of the other point cloud streaming application tested with Steeple? So it's an SDK. I think it is on private beta right now, and its name it's NVIDIA Cloud XR. I will type this, so I think it will be more clearer this way. And it was really great. We have very good feedback on this. NVIDIA plans to improve this tool quite soon. Just a few caveats. We had some issue on streaming to HoloLens 2, but they will apparently fix the issue quite soon. So this is also a very promising way to consume point cloud data if we are able to stream this to on HoloLens devices. And maybe just one thing to complete the answer about rendering and lighting of point cloud. One of the strongest selling points of Steeple is also our visualization shaders. And one of the thing with point cloud, we can simply display some points, which is something just a pixel light up in your screen. But with Steeple, we have some dynamic size, so which is quite common in the field. But one thing that is less common is that the size of the point also depends on its neighbor. And it allows us to have some continuous surfaces. So if you have, for example, a wall with some with very few points, you don't see the points beyond this wall. You will see quite a continuous surfaces, and this is really great for when, especially in virtual reality, you understand much better your 3D data. And this is also very cool, and this was something not that we did not expect at the beginning, but for streaming to but for streaming purposes, like with CloudXR, because the data is much more coherent. You don't have a lot of sparkling points everywhere, and it compresses more efficiently in video streaming. So this means that you have a better result with streaming application using Steeple. So I guess this was the last question. If you have more, don't hesitate. Otherwise, I think I will first thanks Mathieu that co-hosted this webinar. This was very interesting, and I learned quite a lot on mobile scanning. I hope that you also learned quite a few things in this webinar, and it allows you to have some more ideas that unleash your creativities using point cloud data. If you need more information about Steeple, you can go to our website, steeple.xyz. You can also request a trial license if you want. And if you have any more questions, we also we will be happy to answer this. And if you just want to brag and showcase your point cloud, we are also happy to see that. So thanks a lot, Mathieu. Thanks a lot also to Chloe, who organized and handle all the webinar technical and organization. Thanks to Chloe.
Big thanks also from my side, Alexandre, Chloe, and the rest of the team at Light and Shadows for giving me the opportunity to co-present in this webinar, speak about the Navis approach to mobile mapping, and also give one example of how the Navis data can be really further valorized or further leveraged in your great solutions, Steeple, and the rest of your solutions at Light and Shadows. Thanks again.
And my last word will be for all our attendees. Thanks a lot. We had a really cool question. So thanks a lot for this, and thank you for coming to this webinar.